In this example, I'm going to use some row operations to rewrite this matrix before I take the determinant. The idea here is to get a diagonal matrix, or at least get a little closer to a diagonal matrix, so that there's less computations involved in actually finding the determinant. So I'm going to take some steps towards row reducing this. I'll do 2 times row 1 and add that to row 2 to get a 0 in this position here. I'm also going to do row 1 plus row 3 to get a 0 in that bottom left position. Now, both of these row operations are, I'm adding a multiple of row 1 to another row. This type of row operation does not change the value of the determinant. So this next determinant is going to be equal to the one before it. So adding 2 times row 1, I get 0. From adding -8, I get another 0. Adding 4, so I get -5. And then row 1 plus row 3, so that's 0, 3, 2. Okay, so what I notice now is if I just swap row 2 and row 3, I'm going to have a diagonal matrix. So I'm going to swap row 2 and row 3. But that first theorem in this section says that when you do a swap, that changes the sign of the determinant. So now what this next determinant is going to be -1 times that determinant that I had before. So I'm going to need to multiply by a negative to have it equal to the original determinant here. Swapping rows will change the sign of your determinant. So I put that -1 out front, that'll change it back to whatever the original sign was. Okay, now that I have a diagonal matrix, I can find the determinant by just multiplying along the main diagonal. That was our one of those last theorems from section 3.1. So I have the -1 out front, and then to find the determinant of this 3 by 3, I can now just multiply along the diagonal. And so that's -1 out front times -15 inside the parentheses, so my final answer is +15.